So in this lesson, I'm going to teach you how to find the solubility when you know the value for Ksp. Now, remember that Ksp values are tabulated in your textbook or online, so you could just Google and find a Ksp value if you needed one. A lot of the times you'll be provided with one in the problem, so you won't have to worry about that. So let's take a look at a problem. So this one says, what's the solubility of aluminum hydroxide in grams per liter if the Ksp is 2.7 times 10 to the negative 17? Now, one thing to notice is that you're asked for the solubility in grams per liter, and we're working with molar concentrations, so they're in the square brackets. So once we get our molarity at the end, we're going to have to convert it back into grams per liter using the molar mass. So what I've already done is I've written our dissolution expression for the aluminum hydroxide. So the solid is dissolving into the aluminum ion and 3 hydroxide ions. And then I've already written my Ksp for the aluminum hydroxide as well. So that's the Al3 plus concentration times the concentration of the OH minus all cubed. Well, the hydroxide concentration is cubed. Now, what we're going to do is we're going to say that X is the amount of the solid that will be able to dissolve. So what I'm saying is that the aluminum hydroxide is going to dissolve X amount. Now from that, because we know our ratios, the amount of aluminum we get should also be X, but the amount of hydroxide we get is going to be 3X, because for every 1 aluminum hydroxide, there are 3 hydroxide ions. So we're going to use that X value and solve. Okay, so our value for Ksp was 2.7 times 10 to the negative 17th. And that's equal to the concentration of aluminum, so we said that was X, times the concentration of the hydroxide, 3X, and according to our formula, that's cubed. Now you'll notice that that 3 appears twice, and that's correct. Alright, so the next thing we're going to do is I'm just going to multiply this through. So 3 cubed is 27. X cubed times X is X to the 4th. And that's equal to our value, 2.7 times 10 to the negative 17th. Now I'm going to divide both sides by 27. And I'm going to take the 4th root of both sides. And that's going to cancel that, and that's going to cancel that. And all I'm left now is I'm going to just do this on my calculator. Now remember, the 4th root is the same as raising it to the 1/4 power. And on the calculator, this comes out to 3.2 times 10 to the negative 5th molarity, and that is our value for X. However, we're not quite done with this problem. So since we know that the value for X is 3.2 times 10 to the negative 5th molarity, that gives us the molarity, but it doesn't give us the number of grams per mole. So you have to keep in mind that we have aluminum hydroxide, and so we need to find the molar mass for that. Okay, so we have aluminum, we have one of those times 27.0. O, we have 3 of those times 16, and H, 3 of those times 1.0. And I'm going to add all those up to, and that comes out to 78 grams per mole. And now I'm going to use this as a conversion factor to take our molarity, which is really moles per liter, and I'm going to multiply that by the molar mass, 78.0 grams for 1 mole, and that's going to give me a final value of 0.0025 grams per liter, and that right there is our final answer.